So, all of you, good afternoon. Myself, B. Jose Ravindraraj, Assistant Professor, Department of Civil Engineering, JJ College of Engineering Technology. I am here today to talk about the subject of engineering geology. Engineering geology is a very much essential for civil engineering field. It is applicable for structure foundation, design, characteristic of soil, characteristic of rocks, what are the different types of minerals, and the rock formation. Geology, geo, the Greek word geo and logos, the combination of word geology. Geology is also known as earth science. So, engineering geology deals with the study of earth, how the earth formed, structure of earth, and the composition of earth. It is also known as earth science and geoscience. Geology is the vast subject which is devoted to the study of earth. It is deals with the study of earth to understand the structure of the earth and its surface features, to study causes of earthquakes and tsunamis, and why volcanoes form and erupt. Geology is also learn about different minerals which form the building blocks of rocks and how rocks are made and destroyed. It is to learn about Earth's fascinating history, the variety of life forms which have roamed the surface over the millennia, and the dramatic changes that have happened over Earth's long history. What are the significance of geology? There are three types of significance. First one, engineering geology is crucial for the safe and sustainable design, construction of building, and the maintenance of infrastructure. It involves applying geological principles to understand and address the interaction between natural geological conditions and human made structures. It helps prevent geological hazards, optimize material selection, and ensure the long term stability of projects. So, these are all the significance of the geology. Next, objectives of geology. The objectives of geology is geological maps helps in planning of civil engineering projects. The geology provides information about the structural deposition of rock and different types of rocks in the proposed area. Geology helps in determining the earthquake prone areas. If any geological features like rocks fault and rocks fold. So these are all the main objectives of the geology. And what are the applications of the geology? There are several applications of the geology in civil engineering field. So one followed one by one. First one, hazard identification and mitigation, site characterization and material selection, and the design of foundation and stability, groundwater management, optimizing construction process. DRR stands for disaster risk reduction, and finally sustainable development. So these are all the applications of the geology. Next, the vast topic of branches of the geology. There are several branches. So followed by each and every geology, different branches. So first one, starting from physical geology, crystallography, followed by mineralogy, petrology, structural geology, stratigraphy, paleontology, historical geology, and followed by economic geology, mining geology, civil engineering geology, hydrology, Indian geology, resource geology, and last one, photogeology. So these are all the very, very different branches of the geology. Next, scope of the geology. It is a well established interdisciplinary branch of science, and engineering has a scope in different fields as outlined below. There are in civil engineering, mining engineering, groundwater, land pollution, nuclear explosion, oceanography, and space exploration. So these are all the scope of the geology. First, the first branch of geology is physical geology. So physical geology is the primary geology also. It is concerned with the work of the natural process which bring about the change upon the earth surface. It is deals with the earth is there are two parts, main parts, internal and external. The endogenous is the internal surface, and the exogenous is external surface of the earth. There are two agencies and the process that bring about the changes on the earth surface. So who was the father of physical geology? So James Hatton is regarded as the father of physical geology. So these are all the some information of the physical geology. Next, endogenous. What is endogenous and exogenous forces are the two primary categories of agents that shape of the surface. So already I told the endogenous is the internal force. This force originate from deep within the earth interior and are responsible for creating and modifying the surface features. The examples of endogenous are volcanism and tectonism. Tectonisms includes process like plate tectonics, faulting and folding, which can cause uplift, subsidence, and the formation of mountains and valleys. Earthquakes are already all of you very well know for earthquake. Earthquakes are the sudden movements along the faults can cause significant changes to the landscape, including ground shaking and fault rupture and landslides. And another one, diastropism. This encompasses all processes that deform the earth crust. So earth crust is the top portion of the earth surface. So including both the slow and rapid movements. So these are the endogenous, the internal surface of the earth. So another one, exogenous. So exogenous is the external forces. The definition of exogenous, these forces originate from outside of the earth and act on the earth's surface, modifying and existing landforms. This is the definition of the exogenous. So a few examples for exogenous: weathering and erosion, mass wasting and transportation and deposition. So these are the few examples of the exogenous. Weathering means the breakdown of the rocks and the minerals at the earth's surface due to physical and chemical process. And erosion means the removal and transport of the weathered materials by agents like wind, water, and ice. What is mass wasting? It's a downslope movement of rocks, soil, and debris under the influence of gravity. This is the mass wasting. The transportation is the movement of eroded materials by wind, water, or ice. Deposition is the setting of transported materials in new locations, creating features like river deltas and alluvial fans. So these are all the exogenous Earth surface. Second topic is geotectonics. It is very essential for geology, geoscience. It is involves and deals with movement of the plates. So there are 8 types of earth plates. All are very well known for the eight plates, earth plates. It concerned with the movements of earth crust and the deformation caused by geological process, mainly endogenous and exogenous. The following of the 7 major tectonic plates are African earth plate, Antarctic, European and Indo-Australian, North American, Pacific and South American plates. So these are all the 7 major tectonic plates. Next topic, structural geology. What is the structural geology means? It is the branch of geology focused on the geometry, arrangement and internal structure of the rocks, particularly in relation to deformation and the forces that cause it. Structural geology involves the study of rock structures. So each and every rocks having different structures. So structural geology deals with rock structures like folds, faults and fractures and how they form due to various geological process. Especially for different rock structures having some folds and faults and breakdown on the fractures. Okay, these are the geological process by mechanically or manually. Next, essentially, it is about understanding how rocks have been bent, broken, and otherwise deformed over time. Next, fourth topic, geomorphology. It is geomorphology is the scientific study of the origin or evolution of landforms on Earth's surface. It is including their physical characteristic and the process of the different rocks based on the shape. Next one, crystallography. Crystallography deals with, it is the type of branch of geology. It is deals with study of the external forms and the internal atomic structure of the crystalline materials. Crystallography is the experimental science of the determination of arrangement of atoms in the crystalline solids. Next one, mineralogy. It is very much essential. It is deals with the study of mineralogy, composition of rocks, mode and occurrence of rocks, the origin of rocks, stability of rocks, also association their crystalline and chemical structures and their properties such as melting points, etc. It deals with the mineralogy. There are 5 types of mineralogy. Crystallography. Crystallography deals with the studies the forms and the internal structure of crystals. And the physical mineralogy, it is focused on the physical properties of minerals. Chemical mineralogy, it is focused on investigation of chemical composition of minerals and the earth crust. Optical mineralogy is the one of the type of mineralogy. It is focused on uses light to study of the optical properties of minerals, often with a petrographic microscope. And X-ray mineralogy, it is focused on the employs X-ray diffraction techniques to determine the crystal structures. So these are the different branches or different types of mineralogy. Another one, engineering geology. The subject name, engineering geology. Engineering geology deals with the scientific discipline concerned with the application of geological knowledge to engineering problems. It is very much essential for civil engineering. Next, the internal structure of Earth. The Earth has different layers and different parts of the Earth surface. The Earth interior is structured in concentric layers: crust, mantle, outer core, and inner core. These layers differ in composition, temperature, and the physical state. So, what is crust? Crust is the outermost layer of the Earth. It is a solid shell of rocks composed of continental crust. It is the granitic, less dense of the and oceanic crust. The thickness of crust varies from 35 kilometers under the continents to 75 kilometers under oceans. Next, mantle. Mantle beneath the crust, a mostly solid layer, hot layer also. It's a dense rocks, a mix of the majority of earth volumes. So there are divided into two parts, upper mantle and lower mantle. Upper mantle includes the asthenosphere and the semi-molten layers. Next, core. Core is a liquid layer of iron and nickel surrounding the core. There are two types of core: inner core and outer core. The inner core is extremely hot and under immense pressure, responsible for generating earth magnetic field. A solid inner core, a solid primary iron and nickel sphere at the center of the earth, extremely high temperature and pressure. It is discovered in 1936 by Lynch Lemon. Next, how geology applied into civil engineering field. I already told the geology is a crucial in civil engineering as it provides vital information about the Earth's material and the process, which directly impacts the design, construction, and safety of civil engineering projects. Understanding geological conditions are essential for site selection, hazard identification, design of foundation, drainage, earthquake resistant structures, and overall structural stability. So these are all the important application of the geology in civil engineering. Next, rocks. There are three general types of rocks. All of you very well know for the rocks types. First one igneous rocks and sedimentary rocks. Last one metamorphic rocks. What is igneous rocks? Igneous rocks are type of the rock formed from the cooling and solidification of molten rock known as the magma or lava. So this is the igneous rocks. So there are two types of igneous rocks. First one plutonic or intrusive rocks, and second one volcanic and extrusive rocks. So what is plutonic rocks? Plutonic rocks are form magma that cool and solidifies slowly beneath the earth's surface. The plutonic rocks example is granite. So all of you very well know for the granite it is applicable for building flooring. And another one extrusive and volcanic rocks. It is formed from lava that cools and solidifies quickly on the earth surface. The examples of extrusive rocks: basalt. Basalt is the one of the example for volcanic or extrusive rocks. Next one, sedimentary rocks. So what is sedimentary rocks? Sedimentary rocks are formed from the accumulation and consolidation of mineral or organic material. It is sedimentation at the earth surface. The examples of sedimentary rocks is sandstone, limestone, chalk, and gypsum. So these are the examples of sedimentary rocks. The sedimentary rocks having three important types. First one, clastic sedimentary rocks. Second one, chemical sedimentary rocks. Third one, biogenic sedimentary rocks. So it is the important types of sedimentary rocks. And then important types of rock is third one, metamorphic. So all of you very well know for the metamorphic. It is very much essential for civil engineering, building construction. These rocks are these rocks are have been changed from their original form, igneous and sedimentary, or even the other metamorphic rocks by heat, pressure, and chemical reactions. Example, all of you very know for marble stone. This is the metamorphic example. It is applicable for the building flooring, marble flooring, and genesis stone and granite also is example for one of the example for metamorphic rocks. Uh, Thank you for the watching my lecture. Thank you very much. If any query, this is my mail ID. If you have any queries, just send your feedbacks. Thank you very much.